Hello and welcome to part 5 of my SD-Access using zero-touch deployment demo. My name is Roddy Hassan. I'm a technical solutions architect for Cisco Systems. Last thing we did was we created some wireless networks, some SSIDs, and provisioned our WLC so we can see our WLC is provisioned, everything looks good, and we're finally able to get started on building the fabric itself. So the first thing we do when we're going to build an SDA fabric is we need to create some virtual networks. So I've talked a lot about how Cisco Software-Defined Access, one of the big benefits is automation, but one of the other benefits, again, equally as important, is segmentation and security. So the way we achieve segmentation and security in Cisco Software-Defined Access are through virtual networks and scalable group tags, or SGTs. So that's macro segmentation and micro segmentation, respectively. So the first thing we're going to do is we're actually going to create some virtual networks, and that gives us our macro segmentation. So a virtual network, if you don't already know, is just like a VRF, a virtual routing and forwarding instance. So by default, hosts in a given VRF can never talk to hosts in another VRF unless there's actually a router connecting those two VRFs together, which is not something companies generally do. There are sometimes cases for VRF to VRF communication, and most customers and companies will actually connect VRFs together via firewalls so that they can control what kind of traffic is passed between those things. So in Cisco Software-Defined Access, a VRF is called a virtual network, or a VN. So we're going to create those, and in our case, we're going to have two different VNs. One would be for campus users, right, our general employees, and the other VN will be guest network for our guests. And again, generally, you would never have or want your guests on the same network in the same routing domain or the same routing table as your employees, right? There's never any reason to have that. So that's what we're going to do. So we go into the menu here, we go to policy, and we go to virtual network. And we're going to create that. But before I jump there, I'm actually going to show you our SGTs, or our scalable group tags. So I mentioned at the beginning that I already have DNA Center integrated with ICE. So you can see here we've got some scalable group tags that we've brought in from ICE already. And we can create them in DNA Center, and they'll push them to ICE. These ones were originally created in ICE, and DNA Center actually synced and brought them in, but you can do it either way. But we're going to be using a couple of groups, our accounting group and an HR group and our guests group. Those are the groups that we're going to use for our micro segmentation. And micro segmentation, again, these hosts are like accounting and HR would be in the same VN or the same virtual network, but we're going to segment them with policy by their group. So that's kind of when we get into policy at the very end to test things out. That's what we're going to be talking about. So these are our SGTs, or our scalable group tags, and I'll show you later when we do a host onboarding. They are usually what you would do with ICE is you would map a user's AD group to, or an LDAP group to, an SGT, and that's how you identify your users in your fabric. So this is our scalable group tags, SGTs, but we're actually going to go to our virtual networks. So we go into policy, virtual network. We can see we have two default virtual networks in Cisco DNA Center. Default VN is just there because there does have to be a VN in there. Most customers do not use default VN. They just create their own. Infra VN is a special use case, and I'll get into that when I get into the host onboarding section. Infra VN is used for infrastructure devices like access points or extended nodes, which is more of an advanced Cisco Software-Defined Access feature. We're going to click Create Virtual Network here. We're going to give it a name. The first one we're going to create, like I mentioned, is Campus. Just give it a name and click Save. And then we're going to create another one for our guest users, and we'll call it Guest. And we are going to check this box. And all this box really does at this point is it keeps the contexts between the guest VN and the other VNs separate. So you'll see when we get into host onboarding and assigning of IP pools, you'll actually see the guest VN is kind of treated a little different than the rest of the VNs in the network. But it doesn't make a technical difference, but it just kind of keeps things a little more separated because guest virtual networks generally tend to require other features, whether it's a portal or a guest anchor or things like that. So we'll go ahead and we'll click Save. Next thing we need to do is add some scalable groups to our VNs. So for campus, we're just going to use accounting, campus quarantine. We're going to go to add employees and HR. So I mentioned HR and accounting are the ones we're actually going to use for our segmentation for our policy. But I'm just going to add four SGTs to this VN just to have them there. And then for our guest VN, we're just going to add the guests SGT. So anybody that is assigned the tag guests will be in the guest VN, right? Seems pretty straightforward. So that's that. We click save. Those virtual networks are now created, and we can now move on to the next step and actually create the fabric and assign some roles. So when you're creating a fabric, one of the first things you really have to consider is what am I going to hand off to, right? So for traffic to enter and leave the fabric, it needs to go through a border. But what does a border actually connect to? So if we go back to our topology diagram, we can see here our border's next hop router is a fusion router, right? So this is just an IP network. There's nothing special about it. We're going to go up to the data center to get to our shared services and to our to DNA Center itself, as well as over here to the SEPC, which is how we're actually controlling this. So this would be just called an IP transit, right? So there are a couple different types of transits you can create in SD-Access. So let me go in and show you that. So we go to the hamburger menu, we go over to provision and fabric. And we can see our options here. We look at fabrics, right, which we're going to create in a second. And then we can see transit or peer networks. So we're going to create a peer network. And this peer network is that IP transit. It's that path to the fusion router. And why we create this is so that Cisco DNA Center can automate the handoff to that peer network. And I'll get into what that means when I actually get into the border automation. But just to know right now, there's two types of transit or peer networks. One is SD-Access peer or SD-Access transit. That transit is used for multi-site or distributed software-defined access for campus. And that's a special kind of transit, and we are going to do that as well in this demo. But the first one we're going to create is actually just a plain old IP-based transit. And all we really have to do here is give it a name, right? So we're going to call it Bay Area Transit just to kind of go along with our naming convention. And we're going to give it a BGP ASN, right? An autonomous system number. This will be used for the border automation. So when Cisco DNA Center configures the border to hand off its routes to the transit, it will use this AS for the neighboring and for the peer statements. So we're going to use 65535 for our peer AS, right, which is where the IP transit lives. And that's it. And we just click save. Now we're actually going to create the fabric itself. So again, it's pretty straightforward. We go up here, we say add fabric. We're going to call this, why not, Bay Area Fabric. We're going to just start with San Jose for now. We're going to, you'll see here, we can pick which sites the fabric belongs to. We're going to start with just San Jose. We're going to add San Francisco later when we get into multi-site. So we're just going to select San Jose, give it a name, click next, and we're going to pick which virtual networks belong to this fabric. So we just created campus and guest. So we're going to use those, and we're also going to use InfraVN. I mentioned earlier that InfraVN is a special type of VN. It's not actually a VRF. However, it is an overlay in a sense, and it is used for access points and extended nodes. So because we're doing wireless in this demo, we are going to use InfraVN. So we got campus, guest, and InfraVN that we're going to be putting into this fabric. So we just go ahead and click add. We're going to see here it's going to give us a screen with it's going to show us our fabric. Once we click on Bay Area Fabric, we'll see a map and go down to San Jose. And now we can see our fabric. We can actually see the devices that are in the San Jose site. So we've got CP Border 1, which we onboarded with Plug and Play, of course. Edge 1, which we brought in with LAN automation, and our 9800 WLC, which we also did with Plug and Play. So these are showing here in San Jose because that's where we provisioned them to. So now we can actually go ahead and assign our fabric roles. So the very first one we'll do is the easiest one. We just click on the Edge node, Edge 1. Comes up with a dialog box. This is where we assign our fabric roles. I'm not going to cover the fabric roles because, again, if you're watching this video, hopefully you've already kind of understood a little bit about how SDA works. But this is just going to be an Edge node, so we're just going to click this, enable it for Edge mode, click Add, and you can see it's highlighted here or outlined here with the little E. When we actually deploy those settings, this will turn into a solid blue box. we're going to do the same with our control plane and border. So we're just going to click on it. We're going to say control plane and border. Now, when I click border, it does give us another dialog box because now this is where we actually configure the border automation. So now it's asking us for our local AS number, our local BGP ASN. And in this case, we're going to use 65534. So back to when I created the IP transit with 65535, it's going to make a peer to that AS using 65534 as its local AS. So these settings here are different border settings. There are different kinds of borders. There's an external border, an internal border, and an anywhere border. It's kind of out of scope for this demo. Just for now, I'm just going to use an external border, which is basically a default path out of the fabric. It doesn't import routes. It doesn't handle any special routing rules. It is essentially a default route out of your fabric. And this is the default. When you've got these two boxes selected, it will turn it into an external border. So we get in our local AS number 65534. We're going to add a transit that we've already configured, the Bay Area transit, the IP transit that we already picked before. We're going to select a pool. So this was one of the pools I had defined in the beginning. This is the IP address pool that Cisco DNA Center will use to build the BGP peers to the Fusion router. So I go ahead and select our transit pool. Add an external interface. So this is the actual physical interface that connects out to the IP transit. So we go back to our topology. We can see here, I've got gig 101 and 102. Gig 102 is actually the interface we're going to be using here. Gig 101 doesn't actually exist anymore. This is an older diagram. But we're going to go ahead, select gig 102 as our external interface. We don't have to give it a description. You can if you want. And then you'll see here we've got our virtual networks that we can select from. So this is the border automation. And what this will do is as soon as I select one and deploy it, it will build the BGP peer for that VN to the IP transit. Okay, so I am going to do these one at a time, and there's a reason behind that. It's because of the way Cisco DNA Center pulls out the IP addresses from the pool. If I clicked all three and had said deploy, it may be a little random on which address it uses for which VN for the peering side. The problem with that for me is my Fusion router already has a pre-existing BGP configuration on it, and I know or I'm expecting specific addresses to be used. So the only way I can guarantee that those specific addresses will be used with border automation is to select the VNs one at a time in a specific order and deploy them one at a time. So it's more for the purpose of the demo than you would see in production. In production, you could just add them all and then figure out which addresses it used and then redo your Fusion router configuration. But again, for the simplicity's sake, I'm going to do them one at a time so that my Fusion router is already ready and it's already configured for them. So to start with, I'm going to give it the infra VN, and I'm going to click Save and add, and add one more time. And now you can see here, if we zoom in a little bit, it's got a blue outline around CP border 1, and it's got a little C for control plane and B for border. Now I'm going to click deploy and apply, which will make it now. Again, just like with provisioning, we can do now, we can schedule for later, or we can look at a configuration preview. I'll click apply, and it's going to go ahead and deploy it now. And we'll see here these little icons will come up. They look like a refresh icon, but that's essentially DNA Center telling us that it's doing the configuration changes. So they didn't actually pop up because it pushed the configuration changes right away. But essentially what's happening right now is Cisco DNA Center is pushing SDA configuration to the edge node to make it an edge, and it's pushing control plane and border configurations to the control plane border node to make it a control plane and border. So that's happening. And next we're going to go ahead and we're going to do our border automation for the other two VNs. So again, it's very manual. I am going to leave it in the demo just to kind of show you what I'm doing. So we go back in, click the border, click configure. We're going to click our external interface that we had already assigned. And we're going to enable campus. And we're going to save, add, and deploy. It's a little tedious, but again, it's makes the demo go quicker rather than me having to manually configure the Fusion router based on the random order that DNA Center picks the peers in, right? So it's going to go ahead and do that now, and then we're going to do it one more time, and we're going to add the guest VN to border automation. So here's that little logo I was talking about. So while DNA Center is pushing fabric changes to devices, you'll actually see this little logo, and they'll disappear on their own once the configuration is pushed. So while that's happening, I'm going to go ahead and click the border again one more time, configure, select our external interface, add the guest VN now for border automation, click Save, Add, and Deploy. So now, for the last time, it's going to push the peers for the guest VM. So if I was to go look at the Fusion router or the border router, I would see now 3 BGP peers that have popped up. One for infra VN, one for the campus VN, and one for the guest VN. Okay, so now my external connectivity is complete. I've got external connectivity now between my fabric and the outside world, and in this case, it's the Fusion router. Next step is to go into host onboarding and actually configure our parameters for our hosts and our endpoints. So we're going to do that next. So before I wrap up this video, I do want to do something I don't generally do in my demos, but I do want to kind of dive into the weeds a little bit just to show you what border automation did. Again, one of the beauties of SDA is that it is automated, and you generally don't have to do anything at the console to fix anything or troubleshoot anything, assuming everything works. But I do want to kind of just from a nerdy perspective, just show you what happened after I did the border automation. So if we go over to the console of our CP Border 1, and remember, this device, the last time we looked at it, it was sitting in a out-of-the-box state. It was the auto-config prompt. I have not configured or typed anything at this console other than logging in and going into enable mode and typing in some commands just to have them in the buffer. But I've not configured anything on this device yet. It's a fully functioning control plane and border for SDA. It's got an underlay configured on it. It's got links down to the edge node and to the San Francisco control plane node, and it's got BGP up to the Fusion router. So I do want to show you a little bit about what border automation did, what Cisco DNA Center did with border automation. So for the first thing we're going to look at is just look at the BGP configuration. Again, there was nothing on here before. I didn't put in any BGP configuration, but this is what Cisco DNA Center has pushed. So you can see here it's configured BGP with our local AS 65534. It's configured a neighbor in the global routing table with the remote AS 65535. If you remember, that's the IP transit we configured. This address is out of that transit pool. So this is the actual infra VN peer. When I selected infra VN and border automation, this was the peer that was created. It's using loopback or VLAN 3001, SVI 3001 as a source. I'll show you that configuration in a minute. And it's also advertising some ranges. It's redistributing Lisp, which is what Software-Defined Access uses as a routing protocol in the overlay. And it's activating the neighbor and all that kind of stuff. But it's also created a peer in VRF campus. So again, it's using a range from that transit pool that we created. It's configured a neighbor and same remote AS, etc. And we also have one for guest, right? So that's the kind of stuff that DNA Center has pushed to the border through border automation. The other thing it's done is it's actually created these SVIs, 3001, 3002, 3003. If we look at the configuration on 3003, we'll see it's a /30. The other end, like I mentioned, the Fusion router was already pre-configured with the other end of that /30, but it's actually gone ahead and configured that and put it in the appropriate VRF. And if we look at our BGP summaries for each of those VRFs, we can see if we just look at our global, BGP summary, we can see that there's a neighbor that's up and active. We can look at our campus VRF summary, or look at our guest summary. We can see a neighbor up and active, and if we go ahead and do our campus VRF, we can see another neighbor up and active. So again, all of this was pushed and automated from DNA Center. I didn't configure any of this manually, but we've got 3 up and active BGP peers, and we're advertising routes to those peers now. So I'm going to end the video now, and the next video we're actually going to go ahead and do our host onboarding piece, which will allow us to assign pools for our hosts, set up our authentication defaults, and then we can actually test a wired client.